Alrighty guys, welcome to our second algebra test review video. So if you notice, I actually tried to start a video earlier, but then I screwed up because my pen wasn't working very well. So now I got a black pen, and it's going to be working better. So I'm just going to go ahead and re-explain what I was doing. So first of all, the directions. When it says simplify each expression, we did these in the last test. It's review. Every test is going to have this kind of review. So simplify each expression. When it has the letters like these, you got to add like terms. That's really what that means. Whereas down here, when it says evaluate each expression, it means give me a number. So let's go ahead and go through this. If you notice, I drew these arrows. That always remember that means distributive property, and we're distributing the negative to the n squared, distributing the negative to the negative 1, distributing the negative to the negative n cubed. The result of this is a bunch of copying except the negative n squared, and this negative 1 becomes a positive 1, and this negative n cubed becomes a positive n cubed. Next up, we need to put underlines on every single one. We're going to go ahead and put 2 underlines on our n squared. We're going to circle the ones that have no letters at all, a single underline with the 2n, a double underline on this n squared, and we're going to remember that there's kind of an invisible 1 right there that we can put in if we want to. Another circle right here, another triple underline, and again there's an invisible 1 right there. Another circle, and another single underline with another invisible 1. After that, we simply add the like terms, starting with the largest one. So here we have plus 1 minus 8. I'm going to write that over here because I have a lot of students that are telling me this is positive 7, and it's not. This is 1 minus 8. You're starting at 1 on the number line here. And then you're moving left, so you're going to get a negative number. And you move over all the way to the left, and you're going to get negative 7. So just a note on that. So we got positive 1n cubed minus 8n cubed, and that's going to give us negative 7n cubed. So we've taken care of this guy, and we've taken care of that guy. Now let's go ahead and take care of those squareds. We got 8n squared minus 1n squared. Now we have positive n squared with the 7 there. So we've taken care of this, taken care of that. So we've done the n cubed, we've done the n squared, now we go on to n. Positive 2n minus 1n. That's going to be plus 1n, and if you notice, I'm not going to write the 1 because I don't have to, and I'm going to be as lazy as possible when writing my answer. You could write the invisible 1 there if it makes you happy. Then you have plus 2, plus 1, plus 5 for our last term, plus 8, and we're all done. This question has only plus signs, so there's nothing to distribute, so we actually can just start underlining immediately on this question. So we got a double on this guy. We got a quadruple on this guy. Make sure you include that sign there. A circle, a 1, 2, 3, a 1, 2, 3, 4, a 1, 2, a circle, a 1, 2, 3. Okay, starting with the 4s, we got 5 plus 3. That is 8x to the 4th. Okay, we've taken care of those 4s. Now we must take care of the 3s, the next one down. So we have positive 1 minus 7. That's negative 6x cubed. So we've taken care of those cubes. Now we must take care of the squares instead. So the squares, positive 7 and positive 6, that's going to be plus 13x squared. Taking care of the squareds. There's only a single one with the x, so there's nothing to add it with, so we actually just copy it and we're done. Last but not least, the circled ones. Negative 1 plus 5, that's going to be positive 4, and we're all done. Same exact idea on number 3. Not too much, because we've been doing this a bunch. I'm going to go ahead and do this one a lot faster. I'm going to show a little bit less work, and we're going to see if we can just get to it. So, doing it a little bit faster, you don't show all of the arrows. You simply distribute that negative sign, knowing that it's going to all 3 terms. You distribute that negative sign again, knowing it's going to all 3 terms. Is that a minus 4? Oh yeah, I think one of my students was messing with this earlier. Put a little white out on it. Okay, that's a minus 4x squared. Anyways, now that you're doing this, instead of doing all the underlining, I'm just going to look for the highest exponent. All right, so we have an x to the fourth there, and we got an x to the fourth there, and we have an x to the fourth there. So we got 5 plus 7, that's 12. And then a plus x to the 6 is going to be a total of 18 x to the fourth. 5 plus 7 plus 6, so 5 plus 7 is 12, plus 6 more is 18. So now I've taken care of those x to the 4th, so I'm not even doing the underlining, I just know what I gotta do. Now we got the x cubes, 8 minus 5, well that's 3, minus 6 more, now that's negative 3. Go ahead and took care of the cubes there. What's next? We got squareds there. So negative 4 minus 4. That's negative 8. X squared. Took care of that guy. Now, last but not least, negative 2. So it's a lot less work if you do it that way. You know, not doing the arrows, not doing all the underlining. It might be a little bit more comfortable if you want to just do it faster. So anyways, that's up to you. Next up, we have our PEMDAS. We got to remember this. I mean, honestly, you might just want to put that into your cheat sheet. Remind yourself all of your parentheses first, exponents, and then everyone remembers multiplication, division, addition, subtraction. But we really got to remember it, you know? So we just got to do it. So remember these absolute values here? They act just like parentheses at the start. So we're just going to do those first. So we got negative 24 inside those absolute values. Minus negative 1, that really means plus 1. Minus, multiply this together, negative 24. And again, that means plus. The absolute value of a negative number turns it into a positive number. The absolute value of a positive number does nothing to it. It actually keeps it the same. And 24 plus 1 plus 24 is 49. You could use your calculator if you felt like. We don't need to, though. On number 5, same exact idea, and you got to remember there are invisible parentheses around the entire top, invisible parentheses around the entire bottom. So we're going to do this part up here first. So we're going to get 22 minus, and 1 minus 3 is negative 2, all divided by negative 3 minus 3, that's negative 6. A plus and a plus makes this a positive 24 divided by negative 6, which is going to be negative 4. Last but not least, I'm going to scoot this paper up here, this number 6. On this question, again, we have to work on the inside of the parentheses here, 1 minus 3, but inside the parentheses we got a division. The absolute value doesn't do anything to the 5. It's already positive, so it's like 15 divided by 5 normal. Now this one right here, so many students mess this up because they want to do 3 minus 3 first because that's 0. But it doesn't work that way. You have to work from left to right. So we have to do 1 minus 3 first to get negative 2 minus 3. And then we can subtract again. So negative 2 minus 3 is negative 5 times 2, and we get negative 10. All of these questions could be plugged directly into the calculator if you'd like to check your work. That's what I'm going to do just to show you guys. I'm going to do only one of them. I'm just going to do number 6 right here. So to do number 6 on the calculator exactly as it is, I don't care about this alpha thing. All right. So now we're going to go ahead and start with that parentheses exactly like it shows up. 1 minus 3 minus, and now we need to make a fraction. As a reminder, to make a fraction, we hit alpha, y equals, and then enter. And then we type in a 15 on top. On the bottom, we need an absolute value of 5. So to get to the absolute value symbol on the calculator, we're going to hit math, scroll to the right, and hit ABS. Please note, there's actually another option. There's actually another alpha button. You can hit alpha window, enter, and that will also give you an absolute value symbol. Different ways to do it. Anyways, absolute value of 5. End your parentheses. Start a new parentheses. Put that 2 in there. Finally, we can hit enter, and sure enough, we get negative 10. Easy enough. Let's go on to the next page. Oh, we gotta circle our answer over here too. Dropping pens. All right, so number 7. These are evaluate the function. Evaluate, again, means give me a number. However, really, these ones over here should say simplify. So it's kind of not the best wording by this computer program here, because these guys, they got letters in their answer over here, so we got to worry about that. But for the ones that don't have letters, it's very easy. When it says g of -9, we're going to write that right below this. If you notice, oh, that's not big enough. I'm going to write bigger. G of -9, still really not big enough. Okay. G of -9, the t has become a -9. So that t is also going to become a -9. The left-hand side will never change. It's going to be -9 the whole way through. You can just write it a couple times if you want. 2 times -9 is -18. Minus 2 is -20. Easy peasy. Moving on to number 8. W of n equals this guy. Don't be freaked out by the new letters. We're just, again, switching it up. So we're going to write W of -4 right here. That's what it's asking for. Equals, and we gotta put parentheses. Otherwise, you're going to mess this one up because you're not going to have the right thing in your calculator. So now this one, honestly, this is where I would start using the calculator for sure. So to start using the calculator on this one, we're going to go ahead and plug directly in. So we're going to start with a parenthesis, -4, and the parenthesis. Note how I use the small negative sign. I use this one down here, not that one up here. That one used for subtraction. I'm going to use that in a minute, actually. But first we got to cube it. So -4, cube is this button right here above the divide symbol, the caret, to the 3rd power. We're going to scroll over, and now we need to subtract because we're subtracting 5 and -4 squared. So now we use the big negative sign, parentheses, yet again another -4, and we can square it. You could do this again, same exponent button, but there's actually a square button just to go immediately. All right, -80. So we don't have to do any of the work at all on this one, just boom, -80 right away. We showed one step of work with that plugging in. Nice. Next up, number 9, f of -6. So we got f of -6 equals absolute value to -6 plus 1 and the absolute value minus 2. So this one you could do in the calculator, but because it's absolute value, I think it's going to take longer to plug it into the calculator than it is just to do the dang work. So we got -12 plus 1 minus 2. -12 plus 1 is -11 minus 2. That's +11 minus 2, +9. So much easier, actually, than plugging into the calculator. So that went a little fast, but not that big a deal. You just plugged in x equals -6. Just went right for it. Now this one, number 10. Honestly, this is a question that I would deem easy enough that you could probably just show no work whatsoever and still get the correct answer. Because all you got to do is plug in 8, and you get 8 minus 1. That's 7. So you don't really have to show any work for this, and I would totally believe that you were able to do that without showing any work. So that's totally cool. However, if I ask you to show me how you did it, you need to be able to explain to me. Anyways, number 11. You're just plugging in 1 here. So g of 1 equals 1 squared plus 4 times 1. 1 squared is 1 plus 4, and you get 5. Easy enough. I forgot to circle this one up here. Alright, so number 12. This is where things get a little bit different, because now we have to substitute a letter. And whenever you're substituting letters, you got to be very careful to actually replace the entire letter. So, first off, h of, and now we're doing -4n. To do it correctly, my recommendation is to simply put a parentheses where the n was first. So I did 2n, there's my n, it's in parentheses, and then the -4 is on the outside. And now I'm going to put the -4n in. This makes it easier to not make mistakes. Equals negative 8n minus 4, and there's actually no more work to do. That's the end of the question. Same idea on number 13. We have w of a minus 3. So we're going to do negative 2, bracket 3, and we're going to change that a into a big parenthesis, plus 2, that plus 2, minus 2, and we're going to plug in. This one we have 2 steps of work. So we got negative 2. 3 needs to distribute to both. So we got 3a minus 9 plus 2 minus 2. Now we need to add the like terms in the middle. 3a minus 7 minus 2. And there's your final answer. Not too bad. Please note, many students think absolute value is going to turn that positive. It's not. It only turns a single number positive if this is all one number. So you have to wait until after you've plugged a in a later question to make that negative 7 become a positive. You need to leave it just like this. Okay, 2 more of these slightly more difficult ones. So now we're going to plug in n plus 2 where this n is. So f of n plus 2, and this one I'm going to do slightly faster. So I know that n is going to become an n plus 2, so I'm just going to do it right away. And then minus 4. Distribute 2n, 2 plus 2 is 4, and then minus 4. 4 minus 4 cancels, and you just get 2n. Easy enough. Same exact idea, number 15. H of 2x equals 2 parentheses 2x minus 2. That's 4x minus 2. All done. Number 16, please note you don't have to watch the next part of this video if you don't want, because number 16 is extra credit. However, the next page is not extra credit, so you might want to just skip ahead if you're doing that. But number 16 is extra credit. You might as well do it. It's a free point, free bonus on the test. So when it says g of h of negative 3, that's what that says. It means we have to do h of negative 3 first. So we're going to ignore g. We're only doing this inside part first. We're doing h of negative 3 first. H of negative 3, that's easy enough to do. Just like the previous questions, we're going to plug in that negative 3 and then add the 3. 3 times negative 3 is negative 9. Add the 3. And negative 9 plus 3 is negative 6. So now we have h of negative 3 is negative 6. And we're going to replace that h of negative 3 right there. So that's going to become g of negative 6. So h of negative 3 is negative 6. We did this work. These are exactly the same. So we're going to substitute. After that, we could say that g of negative 6, replace that x with a negative 6, because it's from this x squared plus 5. We get 36 plus 5. Don't forget the negative gets in there too, and which is 41. Easy peasy. Didn't even need that calculator on that page. Over here, number 17. Which set of ordered pairs is a function? Explain why. I better at least see some version of a sentence over here. You know, maybe a bullet point or something. Maybe not a complete sentence, but you got to be able to explain to me why this happens. So, A here is 2 goes to 3, 2 goes to 4, 2 goes to 5. This one is not a function. No. And the reason why is because 2 goes to more than one output. That number 2 is not allowed to go to 3, 4, and 5. That cannot happen. Definitely not. I think I made a typo on the actual test now that I just wrote this question. But that's okay. I'll fix it during the test. All right. Letter B here. This is a function because you have 3 goes to 2, 4 goes to 2, 5 goes to 2. Yes, all inputs go to the same output. but that's okay. It's just not the other way around. Now, if you can't do the English version of that, draw yourself a picture. What am I talking about? We got a picture up here. We can easily say on this problem that we have a 2 is our only x value, because all of these are x, y's. This is our domain right here. And here's our range. And 2 is going to 3, 4, and 5. So 2 is going to 3 different guys, and that is not okay. However, if we did it the other way around, over here, we have a 3, a 4, and a 5, and they all go to 2. And this one's fine. So you can't have a single number going 3 places, but you can have 3 places going to one number. Not too bad. All right, number 18, word problem. So a good advice for a word problem is always to read the very last sentence first. The reason why is because that is most likely the question. So let's read the last sentence. Give a reasonable domain and range for this function. Whenever you're writing domains and ranges, you kind of have 2 options. Either those cute little curly Q brackets for things that have all whole numbers, or more likely the case, they're always going to look like this. Domain, range. It's going to have some number, some letter, some number, some letter, some number, some letter, some number again. Where the letter in the middle goes with the domain and range. The number on the left is where it begins. The number on the right is where it ends. So we haven't even read the problem really, but we know we need a domain and range. We know the answer must look like this. That's a good hint for a word problem. We know what the answer's got to look like. Now I'll start reading it. Mr. Richards began driving at 1 p.m. and stopped driving at 5 p.m. when he ran out of gas after having driven 300 miles. Let f of t equal d is a function. Oh, this should be a function. Man, my reading is terrible. Or writing is. Be a function that has an input of time of day and an output of how far Mr. Richards had driven. So, we know that domain are the possible inputs. So it says input time of day. So the time of day was from 1 p.m. to 5 p.m. So we have a 1 to 5. What letter did I choose for time? Well, pretty obvious here in this case. I chose T for time. That's the inside the parentheses. Inside parentheses equals input. T. So the range, you actually have 2 ways to write the range. It's the letter D in the middle here. I think it's pretty obvious that the biggest number is 300. But the other one, there's not another number written here. So the range is the possible outputs. Output of how far I drove. Well, right at 1 o'clock, I hadn't driven at all because I began driving then. If I haven't driven at all, 0 is the beginning of my driving. Please note, an equivalent correct answer to this would be 0 less than or equal to, and you can actually write f of t instead of that letter D. Not very many students choose to do this, but it's okay if you do that. Cool stuff. That's the whole problem. All right. Number 19, explain why the following graph is a function. So you could use the same explanation as up here, but whenever you have a graph, I think it's easier to ask yourself and say, why is the graph a function? It's a function because it passes the vertical line test. That means any vertical line crosses only once. So if it crossed more than once, it would not be a function. But because no matter where I would draw a vertical line, I could draw these literally anywhere. Vertical means straight up and down. No matter where I draw them, they only cross the graph once, you know? It never crosses more than one time. It always only crosses once. Easy enough. Then find its domain and range. Just like we learned in that previous question, if you hadn't known it already, all domains and ranges must be written the same way. So domain and range. Domains and ranges look like this every time. So in this problem up here, we had the letters defined for us. When we don't have the letters defined for us, we're just going to pick x for our domain and y for our range. Every time. So where does our x go? Where's our furthest left x values? Looking at our graph, the furthest left is this guy right here. Now we need to figure out what that one is. So it starts 0, and then -2 is 1, 2, 3, 4 spaces over. So -1 must be 2 spaces over. So it must end up at -3. On the far right-hand side, it goes all the way to the right. If you notice, it goes 1, 2, 3, ends up at 4 over here. Not that bad. Not that bad. You could argue like 3.9 if you wanted to. Range is the up and down instead. Instead of the left and right for the x, we go up and down for y. So the bottom point is down here. It's this guy. Very bottom of the graph. So the bottom of the graph, where does that go? Looks like the bottom of the graph is right here. Appears to be -1. Again, if that's 2, that must be -1. And where's the top of the graph is up here. Where's it up here actually? Gotta be careful. This is not the top of the graph. It's all the way up there. All the way up there is a 4. Easy enough. Alright guys, good luck on your test either tomorrow or Thursday. Have a good one.